My name is Franklin E. Black. I'm the inventor of the Modus disc rotor fan. This technology will replace the helicopter, but it incorporates the best of both worlds, fixed wing aircraft and rotary wing aircraft, in a elegant, simplistic design. This would be similar to a Joint Strike Fighter with vectored gas controlling the thrust. This model would be a coaxial disc in the business jet form. The attributes of Modus technology is far-reaching. This simulates a disc. The disc can be singular or coaxial. It could have a disc shaped like this, with a top disc this way and a bottom disc that makes one singular airfoil. In these discs are planted short turbofan blades that will be servo driven out, that articulates your lift, replacing collective on a normal helicopter. The lift is already built into these, and these are knife edged, high efficient airfoils, such as the GE90 jet engine or the bypass fan technology. The L over D with this knife edge fan blade is a much higher figure of merit than ordinary thick rotor blades. So you might ask, why would you have these blades as they are? Well, the best lift is 20% from the tip end on a helicopter. So that's all the blades we need. This eliminates the huge moment that exists on the helicopter that can damage the blades or can self-destruct so easily. These are planted on this transmission gimbal disc in this manner. And remember, these blades are just a mock-up. This would be about 16-foot diameter for a 3,000-pound vehicle. This unit would carry an actual 3,000-pound aircraft. It's gimbal and simplicity in control. This vehicle has fewer parts than either of its contemporaries, the airplane or the helicopter. Fewer parts translates out into many, many advantages. As you can see, this is a coaxial unit. It utilizes a high-speed, low-torque mechanism, puts the gearbox outside the airframe to avoid noise and stress on the individuals that's using it. It also will allow for a little bit smaller rotor diameter should you need smaller rotor diameters for conflicts that's in the streets. So as you can see, it's gimbaled here. That does the same thing that collective pitch does on a helicopter by moving your lift vectors, and your lift vectors are always perpendicular to the planform. So you can see here, as the helicopter takes off, this being the front of the aircraft toward me, this would be the top of the aircraft. This simulates the bottom. This small motor simulates the power plant. Servo drives would be back here to articulate the roll and pitch moments. To directly manipulate the lift vectors on the airplane, this eliminates the ailerons and the elevator. If you want high angle of attack or higher angle of attack on your wing when you're in the horizontal flight mode, simply pull back on the stick, and your low aspect ratio wing has high angle of attack, so you eliminate the elevators. We would have trim elevators, of course. You're going to bank left or right, you move it this way, that eliminates your ailerons. Those you wouldn't need on the vehicle because it works very well as we see in sports aviation in the auto gyro, the sports auto gyro. The control system is one control system for both modes of flight, which is very important, because if you have two control systems, you've got to try to figure out where you dub off of one onto the other in the flight regime. And as I say, on this particular model, we would have these companion flanges would adapt up for this section here, and then this one here would be the other one on the bottom. They would be tongue and grooved out here on the peripheral to keep the air from going through them. So that eliminates torque. This thing is modularly designed so that the lowest ranking military person could work on it. The blades would all be standardized, and if you lose blades, you could send a PFC out there and simply tell him to take the panel off, change the blade in 10 minutes. These blades would weigh about 12 pounds apiece. Okay, let's stop.